just to find where those probability options are. That's kind of the biggest thing with those. You can just use your graphing calculator today. All right. There we go. All right, so this one won't take quite as long as yesterday. We don't have as many problems to get through. And then remember, we are on advisory schedule today, so we're going to get out at 8. All right, so chapter 4 stuff. We're going to start with the binomial formula that we were doing. So it says 56% of the U.S. adults say they intend to get a flu shot. You randomly select 6 U.S. adults. What is the probability that the number of U.S. adults who intend to get a flu shot is exactly 4? Okay, so formula, let me write it down. You guys, again, are going to have all your formulas. Is as follows. N choose x, and then we take p to the x power and q to the n minus x power. Okay, so n is how many we're choosing, x is how many successes we have, p is the probability of success, and q is the probability of failure. So let's say we want exactly 4 successes. How many people are being chosen in the group? 6. So it's going to be 6 choose 4. The probability of success is what? 56.56. And again, we want exactly 4 successes. And then if 56 is the probability of success, what's the probability of failure? 44, the complement of that. And then 44 is going to go to what power? The second. Okay, so it's how many successes we have 4, how many failures we have 2, and then you just type the whole thing in the calculator. Again, you can use the red calculator on Tuesday when you do this, but you can use your graphing calculator now if you want. All right, so 6 choose 4, and then we have 0.56 to the 4th power and 0.44 to the 2nd power. 0.286. 3 decimal places. Okay. All right, at least 5. So at least 5 is, what are our x values that are going to be considered? At least 5. 5 or 6. And when we say or, remember we are adding. So you're going to do the formula twice, once when x is 5, once when x is 6. Add them together. So 6 choose 5. 0.56 to the 5th. 0.44 to the 1st. And then to that, we're going to add 6 choose 6. 0.56 to 6. And 0.44 to the 0 power. Okay. And then type them each in. First one's going to give me a 0.145. Second one is going to give me a 0.031. Let me add them up. 0.176. Okay. Last one, less than 4. So less than 4 consists of what x values? 0, 1, 2, 3, but not including 4, because it's just strictly less than. So 2 ways to do this. Option number 1 is you can kind of do what we did in part B. So you can find when x is 0, x is 1, x is 2, x is 3, add them all up. Or you can see it's the complement of everything we've already found, right? So it's everything except 4, 5, and 6. And we already know the probabilities of 4, 5, and 6. So you could just do, I think that's the shortcut here, 1 minus the probabilities that we know. Minus 0.145 minus 0.031. And then we'll be left with everything else. .538. Okay. Questions there? Just using the binomial formula there. Okay. Next one, number 15, is just using the information from the previous problem to find the mean, the variance, and the standard deviation. These were the really easy ones that we did. We write the formulas down here. So mean was NP, variance was NPQ, and then standard deviation, as usual, is the square root of that variance. And we have all the information from above, so my N was 6, my P was 0.56. And I get 3.36. Multiply that by Q, and I get 1.4784. And then take the square root of that. We get 1.216. Okay. Can I use the probability of failure? Oh, that is what Q is, yes. 0.44 for this one. Okay, anything else? No one? Okay. Number 16 is just looking at these probability distributions and determining if we have a probability distribution or not. So remember, there were two conditions here. Each individual probability needed to range between 0 and 1, 0 being impossible, 1 being certain, and then all of your probabilities need to add to 1 as well for it to be a probability distribution. So what do you guys think about that first table? It's a no, why not? Okay, so you could always explain that. Got a value less than 0. What about the middle one? No. Also a no. We've got a value bigger than 1. And the last one, it looks like all of my probabilities are good. Let's go ahead and add them up. And I get the sum is 1. So what does that mean? Yes. It's good. Okay. Questions there? Mm-hmm.
It doesn't really matter what that X value is.
It doesn't matter. We're just right now testing that this is a probability distribution. The X values at the top represent the outcomes of that particular experiment, which we don't have any information about, like what those are or where they come from. So no, it doesn't matter what they are for now. Anyway. Okay. Anything else on that one? Okay. Number 17 is our big mean, variance, and standard deviation using the table of values for our probability distribution. And we'll have to create the probabilities here in a second. So again, this is on your sheet. The formula that you see on the sheet looks as follows. I'm going to write the one down for the variance. So it's this guy, x minus mu squared times. There we go. Okay. So remember, we're going to kind of think of this like phases here. We're going to find the probabilities. We'll do that in a second. We're going to have to find the mean because we're going to need that. We're going to do the deviation. That's the x minus the mean. We're going to do the deviation squared, squared piece. Then we're going to multiply it by the probability. And finally, we're going to sum them all up. Okay, so we're not really plugging anything in here. We're just taking it a piece at a time, and that's what's going to create these columns. Okay, so first we need to find the probability of each of these. It looks like employees working overtime hours, how many hours each employee worked. So to find the probability, you do need to know the sum of all of the employees, or the sum of the frequencies here. So I'm going to go ahead and add all those up. I think we were given that at the top. And I get 192. Okay, so now each individual probability, we're going to do how many values were in that row. So my frequency divided by the total. So 6 over 192 gives me, I'm going to try not to round this too much right now. Give it that guy. 12 out of 192, 0.0625. 29 out of 192, that one I'm going to have to round, 0.151. 57 out of 192, 0.2969. 42, 0.2188. 30, 0.1563, and 16. 0.0833. Okay, and then if you want to check at the bottom, I round it a little bit, but the sum of all those probabilities should equal 1 or be really, really close to 1. Okay, so the phases that I'm going to kind of go through with this in our table, we're going to do x minus the mean. So we're going to find the mean. We're going to take that and we're going to square it. Then we're going to take that and we're going to multiply it by the probability. I don't know if I need an extra column there. I don't know why I have an extra column. All right, so let's find the mean next. And again, I think you have a formula for mean on here as well. Sum of all the x's times the p of x's. We could use that in a column, I guess. X times p of x's. We can put that at the end there. If we multiply the x's times the p of x's, the sum of those at the bottom is going to give us our mean. Okay, so it might be a little easier than trying to type that all in the calculator. You can at least see it all written out, especially with all these decimals and things. All right, so x times p of x. So first column times third column. 0 times 0.03125, that's just going to be 0. 1 times 0.0625, 0.0625. 2 times 0.151, 0.302. 3 times 0.2969 gives me 0.8907. 4 times 0.2188, 0.8752. 5 times 0.1563, 0.7815. 6 times 0.0833 gives me 0.4998, so I'm just going to say 0.500 on that. Okay, so if we sum all of those up at the bottom, that's going to give us our mean. So 0.01625, 302, 0.8907, 0.8752, 0.7815, and 0.5. I get 3.412. Okay, so that's my mean. And that's going to be the first part of my answer. It's one of the first things I'm looking for. Okay. So now, once you have your mean, you can fill out the other columns, and you can do it a row at a time if you want to. So you can take your x value minus your mean. So for that first one, it would be negative 3.412. Then you take that value and square it. And remember, when you're squaring something, it is always positive. Okay. And we'll just stick with like 3 decimal places on these. 642, 11.642. And then to get the third column, you multiply it by its respective probability that's in that row. So I'm going to take that 11 number that I have in my calculator, multiply it by 0.03125. And again, to 3 decimal places, I get 0.364. Okay. The sum of that last column then is going to be the variance that you're looking for. Okay, and then we know once we have the variance, you can take it one more step, take the square root of that, and get your standard deviation. Okay, why don't you guys see if you can finish it? Okay, and then I'll put the answer up in a few minutes here. So finish the rest of those rows, sum up that last green column there, get our variance and standard deviation. Whenever you're ready, here's what I got. As long as I didn't hit the wrong button. So you might be off by like 1,000, depending by rounding. Like if you have, or even a couple of thousand, like if you have 2.105, I wouldn't panic. It's fine. It's just rounding. If you're off by more than like 100, like if you have 2.2 or 2.0, that might be a little cause for alarm. So you want to go back and look at your individual rows there, maybe see where you made a mistake. Double check my work, make sure I didn't hit the wrong button. As you can imagine, this will be the one on Tuesday that's going to be worth quite a bit of points just because there's a lot you got to do with it. Math's not hard here, just making sure you type everything in correctly. So there is another one on your paper right below this. I will post the answer to that one online for you guys. It's just an extra practice if you want to try it. So when I put this solution up, I'll include that as well. But it's the same type of problem there, so we won't take the time to go through it in class, but you can use these same columns and do that. The only other thing I wanted to talk about that isn't on this review, but it is going to pop up on the test, is there's going to be a problem that asks you to do the binomial probability, and instead of using the formula with the n choose x, p to the x, q to the n minus x, it's going to ask you to use a table, which is what I mentioned was going to be on the back of your formula sheet here. So if you guys can find that real quick for me. So this table is useful and not useful. So if you have certain probabilities of successes, you can use this table to find the probability of something happening, but it only works for certain values of p. So like the problem that we did at the beginning of this, where the probability was a 0.56, you couldn't use this. You can see that there is no 0.56 here, so it's just increments of 5 that you can use it for. Let's pretend our probability was a 0.55 for that problem instead, okay? So if the probability was a 0.55 probability of success, you can then on the side find your n and your x. Now for that first problem that we did, the n was 6 and the x was 4. So you find group 6, which is kind of about halfway down, almost where that like hole punch mark is. And then within that, you can see all the numbers 0 through 6. So you're going to find row 4 that's underneath the larger 6. And then you're going to go over to where it says 0.55. So the number that you should find when you do that, if you look at 6, choose 4, and go over to a probability of 0.55 is, like a straight edge to this, 0.278. You should see there. Okay, so if any of your homework problems like Math Excel, your 4-2 Math Excel is due on Sunday night, might ask you to use the binomial table, or they might, sometimes they give you like a clickable table that they want you to load up. That's all they're asking you to do, is just locate it instead of using the formula. But you can absolutely use the formula and get the same answer as long as you have those values. Okay. Any questions on that? All right, that's all I got for you today. So I'll post solutions online for that last problem, as well as all the extra practice problems. You guys have those on there. Your 4-2 Math Excel is due Sunday. If you haven't finished it yet, you can take some time in class to do that now. You guys have the bonus worksheet that's due on Monday. You can take time now to do that if you want. Just make sure you show work for all the bonus problems. And then Monday, Tuesday tests. Monday, chapter 3, Tuesday, chapter 4. Okay? Any questions for me? All right. That's all I got.